Welcome to VisualLearn AI, the ultimate fast track to success. In just 2 months, we'll help you unlock your potential one test at a time. With a PhD crafted curriculum, every lesson is designed for excellence. Now let's dive in and solve today's challenge together. Today we're going to tackle a free response question from the 2023 exam. Now this problem involves a cart on a horizontal surface attached to a spring. This is an example of simple harmonic motion, as the spring cart system moves from plus L to minus L. We also see that there's a graph that has kinetic energy and the potential energy. This is an example of conservation of energy. So both of these concepts are being tested together in this question. Our first task is to explain why this graph is a straight line from 4 to 4 on each of the axis of kinetic energy and the potential energy. Let's analyze what the kinetic energy and the potential energy are at each of the extremes of the simple harmonic motion. At point plus L, we see that the velocity is equal to 0 as it explains it in the question. And hence, since the kinetic energy is equal to half mv squared, the kinetic energy at plus L will also be 0. Since the energy is conserved, we already know that at this point the potential energy would be maximum. And we see that because U equal to half kx squared, and since x is maximum, which is the maximum extension at plus L, then at that point the potential energy will be the maximum. We see the same thing at minus L, the velocity will be 0, the kinetic energy will be 0, and the potential energy will be the maximum. We see a different situation at s equal to 0 though. With 0 extension, the potential energy will go to 0. Now we turn our attention to the conservation of energy. The conservation of energy physics principle states that the potential energy and the kinetic energy are constant if no work is done. At this point, we are asked to briefly explain why this is true using physics principle. So we have to summarize what we've done so far. So we write down the heading physics principle, and then we mention the law of conservation of energy. Then we mention specifically that if no work is done, then the total energy is equal to the kinetic energy and the potential energy. And that explains why the graph is a straight line with intercepts 4 joules at the kinetic energy and 4 joules for the potential energy.